Ever wondered what was there before the Big Bang? Here's a thought to grapple with, a question that challenges our understanding of time and existence. We're talking about the Big Bang, the theory that's at the heart of our understanding of the universe. It's a cosmic tale of creation and expansion, a story that takes us back almost 14 billion years. But what about before this monumental event? Was there something before nothing? So buckle up as we journey back to the very beginning. Imagine a point infinitely small, infinitely hot, infinitely dense. Picture this not as a place or an object, but as the entire all-encompassing universe. This is the singularity, the state of the universe just before the Big Bang, and the birthplace of everything we know. This scene is not one of tranquility, but of unimaginable intensity. The singularity is a soup of pure energy, a crucible where the fundamental forces of nature are not separate entities as we know them today, but are united into a single primal force. The elements that make up our world, the stars, and even our own bodies are not yet formed. Here the laws of physics as we know them cease to apply. The concepts of space and time are intertwined, indistinguishable from each other. In this realm, the traditional rules of cause and effect are suspended, and the familiar linear progression of time is replaced by a chaotic ballet of quantum fluctuations. This is a world far removed from our everyday experience, yet it is the crucible in which our universe was forged. It is a state of existence that defies our intuition and challenges our understanding, yet it is here that the seeds of everything we know were planted. In this unimaginably small, hot, and dense point, the stage was set for the grandest performance of all, the birth of the universe. The conditions were extreme, the tension palpable. The universe in its primordial state was like a coiled spring, wound up to its maximum extent, ready to release its pent-up energy in the most spectacular explosion of all time. Yet, amidst this chaos, there was a kind of order, a set of cosmic rules that even the singularity had to obey. These rules, these fundamental principles of nature, were the directors of this grand cosmic drama, guiding the singularity towards its inevitable destiny. And then, in a fraction of a second, everything changed. The singularity could not contain its immense energy any longer. The spring was released, the tension was broken, and the universe as we know it began to unfold. Suddenly, the singularity began to expand. It's a moment that's both unimaginable and awe-inspiring. This wasn't just any expansion, it was a rapid, accelerated spread, an event we now call the inflation of the universe. Imagine the universe as a tiny, dense, and hot point. Now, in a fraction of a second, this point expands exponentially. That's inflation for you. A blink and you miss it moment that set the stage for everything to come. As the universe inflated, it started to cool. And with this cooling, something fascinating happened. The fundamental forces of the universe began to take shape. These forces, gravity, electromagnetism, the strong nuclear force, and the weak nuclear force, are the invisible hands that sculpt the universe. Gravity, the cosmic glue, keeps planets in orbit and galaxies intact. Electromagnetism allows us to see, to feel the warmth of the sun, and even to read these words on your screen right now. The strong nuclear force holds the nucleus of an atom together, while the weak nuclear force is responsible for radioactive decay and nuclear fission. In this expanding, cooling universe, subatomic particles started to appear. Quarks, the building blocks of protons and neutrons, leptons like electrons and bosons, the particles that mediate our fundamental forces, all emerged in this early cosmic soup. It was a veritable particle party with particles of matter and antimatter popping in and out of existence. But as the universe continued to cool and expand, something interesting happened. There was a slight imbalance in this particle party. For every billion particles of antimatter, there was 1,000,001 particles of matter. This one extra particle of matter made all the difference. It's the reason why matter and not antimatter dominates the universe today. As the universe cooled, these particles started to come together, and thus began the next chapter in the grand cosmic drama. The stage was now set for the formation of atoms, the building blocks of everything we know and are. This was the dawn of atoms, the building blocks of everything we know. After the Big Bang, the universe was a hot, dense soup of particles, a place of chaos and energy. Amid this tumultuous environment, the first atoms began to form, a step that would set the stage for the complexity of the universe we see today. These atoms didn't just pop into existence, oh no, they were born out of a process known as nuclear fusion. This process, which occurs when the conditions are just right, sees smaller particles collide and combine to form larger ones. It's like a cosmic dance, where particles whirl and twirl, coming together in a beautiful choreography of creation. The first dancers in this cosmic ballet were protons and neutrons, the building blocks of atomic nuclei. They danced together, under the influence of the strong nuclear force, to form the nuclei of the lightest elements, hydrogen and helium. These elements would go on to play critical roles in the universe, hydrogen fueling the stars, and helium contributing to the stability of stellar cores. As the universe expanded and cooled, these atomic nuclei captured fast-moving electrons to complete their atomic structure. This process, known as recombination, resulted in the formation of neutral atoms. And with this, the universe became transparent to light for the first time, a pivotal moment in the cosmic saga. This was a time of creation, of beginnings. The universe was filled with these light elements, hydrogen and helium, floating around in a sort of cosmic soup. It was a universe of potential, a canvas waiting for the brushstrokes of gravity and time to paint the galaxies, stars, and planets we see today. The Cosmic Symphony had begun, a symphony that continues to play to this day, with each note a testament to the intricate workings of our universe. From the smallest atom to the largest galaxy, everything is a part of this grand performance. But the universe was not yet as we know it. As more time passed, the universe continued to cool and structures began to form. Imagine a swirling dance of matter and energy, a cosmic ballet where the dancers are particles pulled together by the invisible strings of gravity. This is how the first stars and galaxies were born. As the universe expanded and cooled, areas of slightly higher density began to collapse under their own gravitational pull. These pockets of matter became the seeds for the formation of stars. But how does a star actually form? Well, within these dense pockets, particles of gas and dust started to clump together. As these clumps grew larger, so did their gravitational pull, drawing in more and more matter. Eventually, the pressure and temperature at the center of these clumps became so intense that nuclear reactions began to occur. Voila, a star is born. Now let's consider galaxies. A galaxy is essentially a massive collection of stars, bound together by gravity. The formation of galaxies is a bit more complex, but it essentially follows the same principle. Larger regions of higher density collapsed under their own gravity, forming vast structures of gas and dust. Within these structures, stars began to form, creating the first galaxies. Now, here's a twist in the tale: dark matter. We can't see it, we can't touch it, but we know it's there. Dark matter is a mysterious substance that doesn't interact with light or any other form of electromagnetic radiation, but it does interact with gravity. In fact, dark matter plays a crucial role in the formation of galaxies. It provides the extra gravitational pull needed to hold galaxies together. So, from the dense, hot state of the early universe, stars and galaxies started to form, creating the cosmic structures we see today. It's a process that took billions of years, with gravity as the master sculptor shaping and molding the universe. Finally, the universe started to resemble the one we see today. Fast forward to today, approximately 13.8 billion years later, the universe has grown from a hot, dense point of singularity into a vast, ever-expanding cosmos, filled with billions of galaxies, each housing billions of stars. Our universe is no longer the newborn entity it once was. It has matured, expanded, and cooled. It's like a cosmic teenager, still growing and changing, but with a pattern and structure that's becoming more apparent. Let's talk about this expansion. You see, the universe isn't just sitting still, it's expanding. This isn't a simple case of galaxies drifting apart. It's space itself that's stretching. And it's not just expanding, it's accelerating. This discovery, which earned the 2011 Nobel Prize in Physics, has been a game changer. Now, what does this mean for the future? Well, if the universe continues to expand and accelerate, We may eventually face a big freeze. This is a scenario where the universe expands so much that galaxies move so far apart they're no longer visible to each other. Stars burn out. The universe becomes a dark, cold place. But don't worry, this isn't going to happen anytime soon. We're talking trillions of years in the future. And then there's the concept of dark energy. This mysterious force is believed to be driving the universe's expansion, but we're still trying to wrap our heads around it. It's one of those cosmic mysteries that keep scientists up at night. The universe has come a long way. From a singularity, it has expanded into the cosmos we see today. It's filled with galaxies, stars, planets, and life. It's a testament to the power of nature and the laws of physics. And that's the story of our universe, from a singularity to the vast cosmos we see today. So, what do we know about what was there before the Big Bang? We've taken a cosmic journey through time and space, unraveling the mysteries of the universe's inception and evolution. Let's take a moment to recap the key points we've explored. We started with the intriguing proposition that the universe we know and love might not have begun with the Big Bang. Instead, the Big Bang might have been a transformative event in an already existing universe. We delved into the birth of everything, where we discussed how the Big Bang theory suggests that all matter, energy, space, and time itself originated from an unimaginably hot, dense point approximately 13.8 billion years ago. We then looked at the unfolding drama that followed the Big Bang. The cosmos cooled and expanded, leading to the formation of subatomic particles and eventually atoms. This was the Cosmic Symphony, a period of cosmic inflation where the universe expanded at a rate faster than the speed of light. Next, we delved into the birth of stars and galaxies. Over billions of years, the first stars ignited, galaxies formed, and the universe as we know it began to take shape. We then turned our gaze to our universe today, a vast cosmic arena filled with galaxies, stars, planets, and the potential for life. But what about the mysteries that still surround the Big Bang and the origin of the universe? The Big Bang theory, while widely accepted, is not without its unanswered questions and challenges. For example, what caused the Big Bang itself? What was the nature of the universe before this event? And what lies beyond the observable universe? Theoretical physicists and cosmologists are still grappling with these questions, pushing the boundaries of our understanding with mind-bending concepts like quantum gravity, multiverses, and string theory. They're using advanced technologies and techniques to peer deeper into the cosmos, hoping to find clues about the universe's earliest moments and perhaps its ultimate fate. In the grand scheme of things, we are but fleeting observers in the cosmic drama. Yet, our curiosity, our thirst for knowledge, propels us to probe the mysteries of the universe, to seek answers to questions that have puzzled us since time immemorial. While we may never know everything, the Big Bang Theory gives us a fascinating glimpse into the birth of our universe.